Good day, everyone. We are working out number 6 of January 2021 CSEC Mathematics Paper 2. We have a question here involving measurement. We are given the value of pi to be 22/7, and we have a rectangular tank, right, with some dimensions given. It's in the shape of a cuboid, right, a rectangular cuboid. So we are told that the tank is filled with water to a depth of 15 centimeters. Calculate the volume of water in the tank. Okay, so volume of water in the tank, the length by breadth by height. Okay, we can say 50 by 40 by 15. All right, 50 times 40 times 15. We could use our calculators. We get 30,000 cm cubed. That's the volume of water in the tank, length by breadth by height. Let's move on. A cylindrical container shown in the diagram below is to fetch more water to fill the rectangular tank. Okay, we are given the radius and the height. All the water in this container is added to the water in the rectangular tank. Calculate the total volume of water that is now in the rectangular tank. So this is a cylinder. Okay, so the volume of cylinder for the pi r squared h. Pi is given us 22/7 in this question, and the radius is 20 centimeters. 20 times 20 times the height of 21/1. Okay. So what we do is we can cancel 7 into 7, 1, 7 into 21, 3, and we multiply 22 times 3, we have 66 times 400. Okay, which is equal to 26,400 cm cube, right? So 26,400 cm cube. The answer. All right, so this is not the final answer, sorry. We are asked to find the total volume of water in the rectangular tank after we add this water from the cylinder. So the total volume of water now in the rectangular tank would be 26,400 plus 30,000. Okay, so we get 56,400 cm cube, and that's our answer. They showed that the new depth of water in the rectangular tank is 28.2 centimeters. So we use length by breadth by height, and that will now be equal to 56,400 cm cube. All right, and the length is 50 centimeters. The breadth is 40 centimeters, and the height is unknown. That is equal to 56,400. All right, 50 times 40 is 2,000. All right, sorry, 2,000 times by the height is equal to 56,400. So we divide both sides by 2000 in order to solve this equation. Okay. We get 28.2 centimeters. All right, so the new depth of water equal 28.2 cm. All right, so we have shown what we were asked to show. The vertical height of the rectangular tank is 48 centimeters. Determine how many more cylindrical containers of water must be poured into the rectangular tank for it to be completely filled. Okay, so let's see. So the total volume of the rectangular tank is equal to length by breadth by height. We have the total height 48 centimeters. So length will be 50 times 40 times 48. $96,000 cm cube. All right, so after throwing one of the cylindrical containers of water into the tank, we had 56,400 cm cube in the tank, right? So let's see how much space is remaining in the tank. So 96,000 minus 56,400. 39,600. Okay, so so 26,400 cm cube is the volume of the cylinder, and they ask, how many more cylindrical containers of water must be poured into the tank for it to be completely filled. So let's divide. All right, so 39,600 is the amount of space remaining in the tank. And let's divide 39,600 by 26,400 to see how many cylinders we need. 39,600 divided by 26,400. I got 1.5. All right, so 1.5 cylinders, cylindrical containers of water must be poured into the rectangular tank. 1.5 cylindrical containers of water must be poured into the tank, rectangular tank, for it to be completely filled. All right. So 1.5 cylindrical containers of water. This all clearer. All Okay, so 1.5. I'll just put in more. 1.5 more cylindrical containers of water must be poured into the rectangular tank for it to be completely filled. That's the answer for number 6. Thanks a lot for watching and do have a good day.